Good evening, everyone. I hope I am audible. Please write on the chat if I am audible. Okay, okay, Mona, I will see that after some time. And if there will be some problem in that file, I'll upload that file again. Okay. But I don't think there will be some problem in that file. Okay, it's a 0 byte. Okay, I'll see that later on. Okay, so I welcome you all to the 9th day of our training machine learning using Python. So meanwhile, everybody is joining. You can ask your queries if you have from the last sessions. Yeah, it is not a correct file. Okay, so basically the last day file was not saved properly. Oh, it was corrupted. Okay, I'll see if I can do it again because I think it was not saved properly yesterday. Okay. So what we have done in the last class, we have discussed the classification problem statement. We applied logistic regression, KNN. We understood the evaluation of the classification model. We understood different score, accuracy score, precision score, recall score, F1 score, and confusion matrix. All these things we have discussed in the last session, and I hope it's all clear, everyone. You all have understood that well. Okay. Now, today, the topic that I'm going to discuss, it is somewhat to make your model better or to evaluate the model more. How you can evaluate it more. So there are three things that I'm going to discuss today. The first one is ROC and AUC curve. Okay. Second one is your cross validation. And the third one is your feature selection. Okay. So these are the three things I'm going to discuss in our today's session. Okay. So I'll just start in 2 minutes so that everyone can join. So this is basically the agenda for today. And tell your friends and colleagues to join the session as soon as possible. Tell them fast to come fast. Meanwhile, I'll open my book. Okay, so okay, fine. Let's start now. So first of all, I'll tell you what is ROC AUC curve, and then we'll apply that in the practical. Okay. Okay. So ROC and AUC curve. Now, do you know the full form of these two first? Do you know the full form of ROC curve and AUC curve? No? See, basically, ROC stands for receiver operating characteristics. Receiver operating characteristics. Okay. And AUC stands for area under curve. So that's the full form. Okay. Now, why do we use this? Why do we use this? Now, in the last class, if you remember, we discussed about the threshold value in the logistic regression. And what is the threshold value that we have taken in the last class? We considered in the last class the default threshold value. If you remember, we discussed the default threshold value was 0.5, right? That the value greater than 0.5 should be considered as 1, and the data which is less than 0.5 will be considered as 0. So how to decide this threshold value? So to decide that threshold value, we use this ROC and AUC curve. Okay, and this curve also tells about your model, that how good is your model is, how good your model is. So how this ROC curve and this AUC curve is drawn, let me tell you that thing. That's a very simple. Okay, so I'll take here y test value and I'll take here y pred value. Okay, yeah, exact 0.5, exact. So y pred and y test value I have taken here, and you all know what is y test and what is y pred. I don't have to tell you this thing. You all know this, right? So y test and y pred is already known to you. Now let's assume that we have 1 0 1 0 1 0. I am having total 6 samples, 1 0 1 0 1 0. Okay, now the prediction value that we got according to the probability, if you remember yesterday we had done the probability part, and through the probability only we calculated the threshold value. So let's say according to that, what I got is, here I got the prediction value as 0.8. Here let's say I got 0.9. Here let's say I got 0.3. Let's say here 0.7. Let's say here 0.2. And let's say here 0.4. So this is the prediction value that I got for my model in the decimal form. Right now we have not considered any threshold value here. Here right now I am not considering any threshold value. Without any threshold value, I am getting this value now. Now by default, if you go with the default threshold value, what you will consider this? You will consider this as 1. Again this is 1. Then this is 0. This is 1. This is 0. And this is 0. According to the default one, we will consider this, right? So now for this threshold, let's say I'm just taking an example that I am taking the threshold as 0, 0.2, 0.4, 0.6, 0.8. Let's say I'm assuming that I will take this 5, 6 threshold value. Let's say, let's include 1 also. Let's include 1 also. So let's say these are my threshold value which I want to consider. I can consider the threshold value as 0 or 0.2, 0.4, 0.6, 0.8 and 1. I'm not taking 0.3, 0.4. It can be anything. But as for example, I am taking these threshold value. So now just tell me, one more thing. This ROC curve is the curve between, it's a curve between true positive rate versus false positive rate. Just remember this. It is the curve between true positive rate and false positive rate. So what is the formula of true positive rate? The formula of true positive rate is true positive divided by true positive plus false negative. And what is false positive rate? False positive divided by false positive plus true negative. That's the formula. Okay. So we have to use this formula. The curve, the ROC curve is between true positive rate and false positive rate. Just remember this. So basically ROC curves gives a relation between TPR and FPR. Okay. Now, let's say I am taking right now the threshold value as 0. This one. One by one we'll see. So I'm assuming that the threshold value is 0. So now tell me, if I am taking the threshold value as 0, what will be the prediction I will be getting for this data? Tell me, all of you. If threshold is 0, then what will be the output of the first one? 0 or 1? Tell me. All 1. Yeah, very good. It will be all 1 because all are greater than 0, right? All are greater than 0. So whatever we have greater than 0, we'll consider it as 1, and whatever we have less than 0, we'll consider it as 0. So we'll get all as 1 only. All as 1 only. No, not y as y prime. 1 na. We have to convert into 0 and 1. So whatever value you have less than this, it will be considered as 0. And whatever value you have greater than this, it will be considered as 1. That's all. Now, similarly, tell me what will be 0.2. For 0.2, if any number will be greater than equal to 0.2, I will consider it as greater than. Let's not take equal to. Let's not take equal to. Let's take greater than. So greater than 0.2 is 1, 1, 1, 1, 0, 1. Right? It will be on 1 except 0.2. Correct. Similarly, let's take one more example. If I take 0.4, then 1, 1, 0, 1, 0, 0. Tell me, am I right? 1, 1, 0, 1, 0, 0. So like this, you can get for all the threshold value, like 0.6 also, 0.8 also, and 1 also. I'm just skipping that, okay? You can calculate all the other thing. Now, when you got all these things, when you got all the prediction, now the graph will be plotted. So, before the graph will be plotted, the TPR and FPR will be calculated. Okay? So, let's come here. Let me take a graph. So let's say this is your true positive rate TPR, and this is your false positive rate, which is FPR. So this point is your 0. Let's say this is your 1 and this is your 1, because the maximum value is 1 only. Okay, so that's why we are taking here 0, 1, 1. So this point will be your 0, 0 basically. Okay, now let's calculate first of all true positive rate and false positive rate for the y0, for the y threshold 0. Now tell me, for the threshold value of y as 0, what will be true positive rate? how many TP we are having? TP 3 1, correct? We got here 3 1. So let's make it as here 3. Then divide by TP plus FN. So TP is again 3. And FN, what is FN? What do you mean by FN? 1 0 is FN. 1 0, false negative, 1 0. So 1 0, how many 1 0 we are having here? Do we have any 1 0 here? No 1 0. So your TPR will be 1. Your TPR will be 1. Similarly, what will be your FPR? What will be your FPR? FPR will be FP. FP means false positive. False positive means, what do you mean by false positive? 0 1. 0 1 is the false positive. So how many 0 1 you can see here? See, this is 1 here, then here, then here. Again 3. Divide by 3 plus TN. TN stands for GN, 0 0. So do we have any 0 0? No 0 0. So it will be 0. So it will be again 1. That means for the threshold value of 0, we got the TPR as 1 and FPR as 1. That means which point? Can I say that this point? Yeah. So this is your threshold of 0. Am I correct? Tell me everyone. Is that thing clear? So this is your threshold of 0. This is your 1, 1 point. Okay. Similarly, now let's plot for y of 0.2. Y of 0.2. Let me plot one more. So y of 0.2. So TPR is equal to, I don't think so, video is dull. Please change the quality of the video. It will be better. So TPR is equal to, tell me what will be the value for 0.2. TPR to true positive. True positive how much? 2. I'll write here 2. So 2 divided by 2 plus FN. FN means 1 0. How many 1 0 we are having? Only 1 we have 1 0. Only 1. Only 1. So it will be 2 plus 1 will be 2 divided by 3. And how much it is 2 divided by 3? It is approximately 2 divided by 3. It is 0.6 or 0.7 approximately. So let's say it is 0.7 approximately. 0.7. Okay. Then similarly, FPR is equal to false positive. False positive means 0 1. So how many 0 1 we are having? 1 1 2 3. We have 3. So it will be 3 divided by false positive plus TN 0 0. How many 0 0 we are having? There is no 0 0. So it will be 1. So the point is 0.7 and 1. So 0.7 and 1. So can I say that it is somewhat here? Tell me, can I say that? So this is your y of 0.2. Tell me, correct? Yeah. So similarly, if you plot the other points, you will get all the points plotted on the graph. So let's say I have 1 point here. Let's say I have 1 point here. So we have to plot total how many points? 1 2 3 4 5 6. 6 points we have to plot. So let's say you have 1 point here. and you have 1 point here, let's say 0 0, you'll get 1 0 0 also, maybe. Okay, so let's say these are my 6 points which I got. Now after plotting all these points, you have to just add this and merge this. You have to simply draw this line. So let's say 1 2 3, I think the 1 2 3 4, wait just a minute. It will not be this will not exactly in a practical way. You will get somewhat here. Let's say I'll take it here somewhat. Okay, let's say, so let's say here only. So I'll just add this line like this. I added this line. Okay, I've added this line like this. Okay, now this curve that you got here, this one, what is this called here? This is the area under curve. Area under curve. And if I draw a center line here, let me draw a center line like this. Now, more area we have above this line, that means here, more area, more better your model is. That means if after this center line, if you have more graph, more portion of the graph, your model will be more better. Your model will be more good. So your best model will be, let me show you one image from Google, if I can find out. Maybe that image will be better for you to understand. You can look at this image. Look here. If you see this violet line here, this is the perfect classifier. This is a perfect one because this is the maximum that we got here. This is the center line. So more and more above this graph, more the better the model is. Okay. And this area is the area under the curve, the bottom portion. This is the area under the curve. Now, how to decide threshold value? We got the graph. Now, how to decide? Now here, it depends on the data set to data set. It depends on the application. It depends on the requirement. Let's say, just tell me, let's say I am a domain expert or I am an expert or something, and you are making a project for me, and I am asking you, I am telling you that I want a higher true positive rate. I want a higher true positive rate, and I don't want any false positive rate. So tell me which point you will consider here. Let's say this is your point A, this is your point B, this is your point C, D, E. We have 6, 1, 2, 3, and this is F. So tell me which point you will consider if you want higher true positive rate and no false positive rate. Which point you will consider? Yeah, point A. That means whatever value we have here on as a threshold, I will consider this point because here the TPR is high, but we have 0 false positive rate. The false positive rate is 0. No. You have to consider C. If I say I want to consider both higher. I want both as higher. So I can consider C or I can consider D. Right? So like this, you have to decide according to the application that what you have to give the priority. If you want to give the priority to TPR, which point you have to take. So like this, you have to check the graph and you have to decide which threshold value would be the better one. Or what you can do, you can calculate the accuracy for each threshold value that you can do. And then you see where you are getting the good accuracy or maximum accuracy. Then you can go with that threshold value also. Okay. So in sklearn, in scikit-learn, we have a function, we have a library which will do all these things for you, which will calculate the threshold, everything for you. You don't have to do much. So that I'm going to explain now in a practical. So this is your ROC and AUC curve. So this complete curve is known as ROC curve. Okay. And this curve only, this part of the curve is only known as AUC curve. So that is all for this. Okay. Now coming to the practical, let me demonstrate this. Okay. Higher TPR indicates, see here, if I'm saying that the TPR is higher, it means that your FN is very low. FN is very low. False negative is very low. That's the meaning of TPR. Okay. Okay. So now this is a threshold value, na? So with the threshold value, you can get your prediction. Yesterday I told you how to change the threshold value, na? Okay, so I have simply opened the last day file, the last day collab file which we have used. Okay, and I'm going to run the complete file again by uploading the data set. All of you, please hit the like button. Present here, everyone present here, hit the like button. Like this video. Okay, I'll go to runtime and run all. Okay, so now I have completely run the code and I'm just using the same day file, the last day file which we have used. Okay, now here we will see this one. I didn't say threshold value. So we'll calculate the ROC curve, we'll draw the ROC curve, and then we'll see what threshold value, for what threshold value we are getting the highest accuracy. We are getting the highest accuracy or the maximum accuracy. This we will see now. Okay. So how to do that now? Let me tell that to you. So first of all, I will import from sklearn. Acha, before that, let me import that first. From sklearn, import sklearn.metrics import ROC underscore curve. ROC underscore curve. Now if we have to change the threshold value, just tell me one thing, what we consider as a prediction, Which function we use for the prediction? Predict or predict probability? Which one we will use? Predict or predict probability? Tell me. Receiver operating characteristics. I just now completed this and you are asking ROC. Here what we have completed? I explained here ROC only, na? Yeah, predict probability, correct. So what I'll do is that we have done yesterday, this one, yeah. This one I'll copy here. And let's say I will write here my pred. I'll store it in a variable. My pred is equal to log dot predict probability x test colon 1. And you all remember, I hope you remember why we have taken this one. So you all know this. So these are my prediction value that we got without the threshold. Now from this one we have to for this one, we have to check the threshold and do everything. So now we'll calculate the threshold and everything. So what I'll do is I'll define three variables because ROC curve gives you three results: FPR, TPR, and threshold. So I'll write here FPR. It should be in the same sequence: TPR, comma, thresholds. Thresholds equal to ROC underscore curve. And here you will pass your y test, comma, my pred. Y test, comma, my pred. And now if I run this, done. So you calculate, basically the model, this library calculated the FPR and TPR for all the threshold value that is possible. Okay. Yeah. ROC, AUC, all these things, precision score, recall score, confusion, F1 score, all these are applicable for the binary classification only. Okay. So now let me make it, save this in a data frame so that we can properly visualize this. Okay. So I can write here, df is equal to pd dot, just a minute. Let me keep it side. Okay, so pd dot data frame. I'll make a blank data frame. Now in the data frame, I'll add some column. The first column is your FPR value. So here I will pass FPR. Second column is your TPR value. So here I will pass my TPR. It is lagging, TPR. And the third one is your threshold value. And here I will pass the thresholds. Okay. Now if I print this df, now look here. So we got total 18, 0 to 17, to total 18 threshold value we got. So 1.99, 0.99, 0.85, 0.85, 0.68, 0.63, 0.51. For each threshold value, these are the FPR and TPR value. These are the FPR and TPR value. See, we got the FPR and TPR for all the threshold value. Okay. So these are my possible threshold value. Now we'll draw the line of curve, ROC and AUC curve. And let's see how the curve looks like. So for that, let's plot that. So I'll write here, import matplotlib dot pyplot as plt. Okay. Now plt dot plot FPR versus TPR. If you remember, the graph is between false positive rate and TPR. So FPR versus TPR. Let's say the color I want is as orange color. Okay. And let's say the label is your ROC curve. Now if you see plt.show, Okay, you can see this is the ROC curve. Let me make it. Okay, see, this is the ROC curve that we got for each of the threshold value. Okay. Now, if I want to draw the center line, center line, if you remember that center line, I want to draw that center line. So how to draw that center line? PLT dot plot. Now just tell me everyone, if I want to draw the center line, what would be the coordinate? I want to draw a line here, center line, then like this. I want to draw a line like this. This line I want, this line. So what would be the coordinate value? What should I pass here as a coordinate value? Yeah, it should be 0, 0, 1, 1. That is the correct thing. 0, 0, 1, 1. But in matplotlib graph, by default, this is your 0 point and this is your 1 point. Y-axis is reversed. By default, y-axis is reverse in the matplotlib. It's by default reverse. So in that case, you have to write here 0, 1 and second point also 0, 1 like this. And let's say the line style should be a dotted line. Okay. Okay, look at here, we got that line here. Okay, this is the line that we got. Now, according to the actual thing, if you write here 0, 0, 1, 1, see what line you are getting. See, we are not getting any line. So, in the matplotlib, it is reverse. That is why we have to write in this way. Okay. So here we got that line. So that is all. That's all we got the graph. And this is the ROC curve that we got. Now let's calculate where we got the maximum accuracy. So you just have to use the loop and calculate the accuracy for each of the threshold value and then do it. So I'll just write that code now very fastly. We have already imported the accuracy score now. Okay, let me import that again so that it would be a better. Okay, so let's say accuracy. I'll store all my accuracy here. So accuracy equal to this. Now for I in thresholds. That means I am taking all the value of the thresholds one by one inside I. Okay. Now y underscore pred. It's now I'm predicting my new value of y. Now here what I'm doing is, see, basically, wait. Where is that variable gone? This one. I will use this my pred variable. Okay, my pred variable. So this one only we have to use for checking the accuracy, right? So if I write here my pred greater than threshold. Now, do you know the function of numpy, which is a where function? How many of you know about this function? Tell me. Where function. Sangeeta, see, basically in the matplotlib, the graph is reverse. This is your 1, this is your 0 in the terms of y-axis. And in the terms of x-axis, this is 0, this is 1. This is what I'm saying. Sorry, I have given, this is 0, this is 1, this is 0, this is 1. So that is the thing that we have in the matplotlib. It's reverse. Okay. Now, what is the use of where? Yeah, for the condition we use where. So in the first argument of the where function, we pass the condition. So if I'm writing here np dot where, now this is the condition that I want to check. That means I want to check, is my pred value. Okay, so am I audible now? Sorry, I was disconnected. I'm sorry, I was disconnected. Am I audible now? Please write on the chat if I'm audible. Yeah, yes. Okay, I was disconnected. So right now we are okay. Okay, fine. Yeah, so what I was saying here, that in this case, what it will do, it will check this condition. It will check this condition. And if this condition is true, it will assign the y pred value as 1. Otherwise, it will assign the y pred value as 0. So this is what we do in the where function. This is what we do in the where function. So now after doing this, your y pred will contain all the thing. Now we'll calculate the accuracy. So let's say acq, that is accuracy only, acq. Or directly we can append this. So accuracy dot append accuracy underscore score, and in the accuracy score we will pass the y test value and your y underscore pred value, because we have to check with this one. Okay, this is my final prediction. Okay, so now after doing this, you will get your all accuracy. So let me run this. Okay, now if I print the accuracy here, or let me concatenate this to my data frame. So what I can do is a df of accuracy, is equal to accuracy and df. Okay, now look here. We got accuracy same for everyone. How it is possible? Just a minute. What a mistake I have done. Oh, sorry. Here I have to pass I. We have to pass here I, na? Okay. We have to pass here I. Okay. Now you can see we got the accuracy for different threshold value. Now I can do one thing. I can sort this data. So df dot sort underscore values, and I want to sort this by accuracy. Okay, in descending order, ascending equal to false. So at the threshold value of 0.5191, you are getting the maximum accuracy, that is 88.75. See, here we calculated accuracy. You can calculate F1 score, because basically this is an unbalanced data set. We have to focus on F1 score. So you can calculate F1 score if you want to do that. Okay, but I have taken your accuracy score as for example. So for this one, I am getting the maximum accuracy score. So we got the accuracies for each threshold value. And now you can decide which threshold value would be the better one. So that's how we use ROC curve to decide the threshold value. So am I clear to all of you? Tell me. Is that thing clear? Okay. Now moving on to the next part, which is cross validation. Cross validation. Now, first of all, let me tell you the concept of cross validation, the theory related to cross validation, and then we'll come to the practical part. Now, why do we do this cross validation? What is cross validation? And why do we do this? See, whatever accuracy you are getting from the model, can you tell surely, can you say that surely that this model will work in any case? Whatever model we are creating, how can we sure that this model is the best model? It can work in any case, any data. So for that, if we are doing it now, normally we cannot do it in that way. So by doing cross validation, we check whether the model is working perfect in every case or not. So in this case, we make sure after this whether the model is good or not. After applying this, we will be sure that whether our model is a good model or not. So we have a different types of cross validation. You can apply any of the cross validation. There are different types. So what is the first cross validation? The first cross validation that we call it as holdout. Holdout validation approach. Holdout validation approach. Second one is your k-fold cross validation, which is very much famous. Okay, k-fold cross validation. Third one is your stratified k-fold cross validation. Okay, stratified k-fold cross validation. Fourth one that we have is leave one out cross validation. And the last one, the fifth one, is the repeated random train test split cross validation. So these are the 5 types of cross validation. This is also known as shuffle split. So So I'll consider, I will explain all these five, and I will discuss the practical also of all these five. Okay. So now, what are these five? First of all, static hold out validation approach. This one. This is our traditional method only. Do you remember on when we have applied linear regression in the train test split, we used different random state and we calculated the accuracy? Do you remember that step? So that is only called hold out validation approach. So it is a basic splitting technique where we use which function? Train, test, split. So whatever we have used till now for splitting the data, that was not other than hold out validation approach only. It was hold out validation approach only. And that is the traditional way, the generalized way. Now other one, now I'll explain that. This one you all know, so I don't have to give practical for this one. You all know this, right? Now for the k-fold cross validation, now what is this k-fold cross validation? Let me explain that now. Okay, k-fold cross validation. Now here we basically divide the data into different folds. Different folds, that means you can say different splitting. So let's assume, I'm assuming, let's say that k is equal to 5. Now this k value can be anything, 5, 10, 15, anything that you want, anything. I'll show in the practical, there will be no difference. There will be no much difference if you take different value of k. So I'm just assuming that k value is 5 right now. And let's assume that total number of samples, including the training and testing, I'm having right now 100. So this is the example that I'm taking here. I am having total 100 samples where k is 5. Okay, now how this k-fold cross validation will be doing this? Let me explain. Now what it will do, it will split the data, into 5 equal folds. So in each fold, how many samples will be there? 20 samples each. Because we have total 100 samples, so 100 divided by 5, it will be 20. So if there are total 5 fold, there will be total 5 iteration. Remember this. 5 fold means 5 iteration. Now, what it will do in the first iteration? In the first iteration, now see how it divides the data. First of all, let me tell you that how it divides the data. It divides the data in a sequence. That means in the first fold, the data will be from 1 to 20. In the second fold, the data will be from 21 to 40. In the third fold, the data will be from 41 to 60. In the fourth fold, 41 to 60. 61 to 80. And in the fifth fold, 81 to 100. So first of all, tell me, is this splitting clear to all? How it is going to divide the data into 5 parts? Tell me. So we got total 5 fold, 20 samples each. The first 20, next 20, third 20, fourth 20, and the fifth 20 samples. Is this thing clear? Tell me, everyone. Okay, fine. Now, after this, what you will do? No. I'll tell you what is test data, what is training. I'll tell you. Just right now, just understand what I'm explaining. Right now, it has just splitted the data into 5 equal fold. Now, in the first iteration, let me write here all the iteration. Second iteration, third iteration, fourth iteration, and fifth iteration. Now, in the first iteration, the first 20 samples will be used for testing, and the remaining samples will be used for training. Let me write in another color. Wait. This is the first iteration is here, na? The first iteration, this will be your train, and this is your test. So this is about the first iteration. In the second iteration, this will be used in the testing. In the third iteration, this will be used in the testing. In the fourth iteration, this will be used in the testing. And in the fifth iteration, this will be used in the testing. Like this. So train, same thing here, same, train, same. So tell me, is that thing clear? All of you? Is that thing clear? So in the first iteration, the first 20 samples will be used for testing. In the second iteration, the second 20 samples will be used for testing. In the third iteration, the third 20 sample will be used for testing. In the fourth iteration, this will be used for testing. In the fifth iteration, this will be used for testing. So 80-20. Now, in all that iteration, you will get some accuracy. Tell me. In all the iteration, you will get some accuracy. So let's say here you got accuracy 1, here you got accuracy 2, here you got accuracy 3, here you got accuracy 4, here you got accuracy 5. So if the mean of all these accuracy is also good, then I can say that the model is also good. If the mean of this all accuracy is also good, then I can say that the model is also good. So this is your k-fold cross validation. So tell me, am I clear to this, everyone? Is that thing clear? Yeah. Is it clear to all? Okay. Yeah, fine. No, depends on the number of k. Depends on the k value. If you take the k value as 10, it will take total 10-fold. So 10 and 90. So there will be 90 and 10%. There will be a 90% and 10%. It will depend on the value of k that you are taking. Sangeeta. Okay? Fine. Now the second one, stratified k-fold cross validation. Now what is this? Now this is totally same as k-fold cross validation, but what is the difference? Let me tell you the difference what we have here. Let's say you have a data set. Okay, now look at this data set, everyone. This is the class here. Setosa, versicolor. Yeah, correct, Mona. Yes, Virginica. So I'm having 3 class. Now just tell me, everyone. In the k-fold cross validation, if I consider the first 20 in the first fold, that means from here to here. So how many class I am covering here? How many class I am covering here? Just look at the data and tell me. Out of 3 class, how many class I am taking here? Only 1 class. Only 1 class. No, there is no rule for selecting that k value. There is no rule. Only 1 class. That means the other 2 class will be missing, right? So tell me, what do you say? Will that be a good training? Will that be a good training? Tell me, will that be a good training? No, na? So that is a con of your k-fold cross validation. That is a cons. That's a con. That if your data class is in a sequence, or if your data is a imbalanced data, so in that case you may not get the correct number of class in each fold. So in the stratified k-fold cross validation, when the splitting is done, it makes sure that it takes all the class in a good proportion. It makes sure that it takes all the class in good proportion in all the folds. If you are creating 5 fold, in each fold all the class will be present, and it will be present in good proportion. Maybe equal. If you have equal number of samples, it will take equal samples in all the fold. Understood? This is your stratified k-fold cross validation. Okay. Then the fourth one, which we don't use for the larger data set. We don't prefer this for the larger data set because this is a very time-taking process. I'll tell you what is this leave one out cross validation. Now see, the name only tells you about this. Leave one out. That means one by one, it will take only one sample. What it does actually, let's say you have, I'm just taking example of 10 samples only. I'm taking the example of 10 samples only because 100 samples will be a little bit difficult for me to right now to write all the 100 samples. So I'm assuming that I'm having total 10 samples. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if you have 10 samples, there will be total 10 iterations. There will be total how many iterations? 10 iterations. Like this, there will be total 10 iterations. In the first iteration, it will consider this one as a testing, the first sample as a testing data, and the remaining 9 sample as a what? Remaining 9 sample as a training data. Training data. In the second iteration, it will consider this 2 as a training, 2. Remaining 9 as a testing. In the third sample, it will consider this 3 as a testing. 3 as a testing. Remaining 9 as a training. Then 4 as a testing. Remaining 9 as a training. So if you have 1000 samples, how many iterations will be there? 1000 iteration. 1 lakh samples, 1 lakh iterations. So just remember, like just you can imagine how many iteration it is going to do. So it is going to consume very larger memory and very large amount of time also. And that's why we don't prefer to use this. But this is also one way which you can prefer for a smaller data set. Okay, so this is your leave one out cross validation. Okay, this is the fourth one. Nah? Okay, leave one out cross validation. Okay, now the last one, which is the fifth one, repeated random train test split. Now this is very simple. This is a hybrid of leave the first. In the second iteration, second data will be testing. In the third iteration, third data will be testing data, like this. Hybrid of train test split. That means the first way, hold out validation approach, and k-fold cross validation. It's a hybrid of train test split and k-fold, mixture of these two. How it will be 8, Harendra? In the second iteration, it will cover this also. No? It will not leave one. It will consider one also. Okay. So it will be 9 only. No? In one iteration, it will take only one sample for training. And remaining one will be for test. One sample for testing and remaining one will be for training. Remember this. So is the fifth one clear, everyone? It is a mixture. It is a hybrid of the first one, that is train test split, and the k-fold cross validation. Okay. So these are the different types of cross validation technique that we have in machine learning. That's all. Okay. So now let me demonstrate this, how to do this in a data set. Let's understand this. Okay, so let me take a new file. I'll make a copy of this only because this only we will be using. See, you can try all, Girish. You can try all. Whichever you will get the. This is just a evaluation technique, na? It's also evaluation technique. So you can try all the thing. It will not harm any much. So you can try everything. Okay. So cross validation. Okay. So I'll use this for the same data set. Okay. Let me upload this. Just give me a minute. Okay, so I'll apply the pre-processing. Okay, so till here I have run the code before the splitting of data, because after this we have to use that cross validation. So before the splitting of data, I have run on the complete code. Okay, now from here I'll write my all the validation type. So I'll just delete all these cells. I'll delete all these cells. Okay. Okay, I'll share the link of this collab file on the chat. All of you present here, please hit the like button. Okay, I've given the new collab link. You can take it from the chat. Okay, fine. Now the first one, let's say I'll tell you holdout validation approach. Holdout validation approach. Okay. Now from sklearn dot model underscore selection model underscore selection import train test split from sklearn dot linear underscore model import logistic regression, because we have to apply logistic regression only for calculating the accuracy. Then xtrain xtest ytrain ytest is equal to train test split x comma y comma train size. See, this already we have done, so I hope you don't have any problem in this. Let's say random state is 0, 0, 1, whatever you want to take, you can take it right now. Then we'll create the model. So model is equal to logistic regression. Then we'll fit the model. So model dot fit x train comma y train. Then we will store all the we'll store the accuracy. Just give me a minute. Okay, fine. So model.fit, and now in the result I'll write here. See, the accuracy score that we calculated now, we can directly calculate the accuracy score through this function also, model.score. This function also we can pass to calculate the accuracy score. Like text and ytest, and I'll print the result here. So this is the traditional way that we have used so many times. And we got the 91% accuracy for this random state 0 that we got. If I change this to 1, I'll get some other accuracy. This is one other traditional way. Now the other way, that is k-fold cross validation. Now I'm going to tell you that thing. So that you have to understand. So k-fold cross validation. K-fold cross validation. Now here for the k-fold cross validation, let me come to copy the complete code. Okay, we have done already. Now here what we will do, we will not really require this line. This line is not required because we are not going to use this technique. Okay. Now we'll import that k-fold. Okay, wait, I'll do it here. I'll write here itself. Import k-fold. Import k-fold. Now in this k-fold, what I'll do is, I don't require this line, so I'll remove this line because we are not doing this. Now here, model equal to logistic regression, this will be same. And after this, you have to create an object of the k-fold validation. So let's say I'll create a variable k-fold equal to, and here I will pass this k-fold. I'll call this function, this class k-fold. And in this k-fold, what you will pass here, the number of fold. So let's say I'm taking here 5 right now. Later on, I'll change it and I'll show you the difference. I'm taking here 5 right now. I'm taking here 5 k-fold. So that means I want to create 5 fold here. Okay. Now, I'll import numpy also to calculate the mean. Now after this, to train the model, we don't train it in this way. If you are using cross validation, we never train the model this way. So how we train the model? We'll import one more library, which is your cross validation score. Cross validation score. And we'll call this function to train the model. So I'll write here, I'll remove this line. So result equal to cross validation score. And here you will pass the model. Now this model can be any model. We are using logistic regression, so it will be applying logistic regression. Okay. So model, comma, x, comma, y, x, comma, y, your x and y data you will pass here. And then you have to pass here which cross validation you are applying. So CV is the argument that we are passing here. So which cross validation we are applying? We are applying this cross validation. So CV is equal to k-fold. CV is equal to k-fold. Now if you print the result here, let me take a variable results, because here I'll get multiple accuracy. How many accuracy you will get here? Total 5 accuracy you are going to get here. Now look here. 0.78 is the accuracy for the first fold. 0.9 is the accuracy for the second fold. 0.825 is the accuracy for the third fold. This is for the fourth fold, and this is for the fifth fold. So we just have to take the average of all, and then we'll see. So let's calculate the average. NP dot mean. So see, so on an average, I am getting 81%. 81% after applying the k-fold cross validation. Okay. Now the same thing if I want to apply stratified k-fold cross validation. Now let me tell you that. Stratified. Okay, fine. So in this one, you don't have to change much. You just have to change it here. Import k-fold. I'll write here stratified k-fold. Stratified k-fold. Now here, here you will change. Now here, let's say SK fold. I'll give the name as SK fold. Now in this SK fold, same thing. How many split you want? I want 5 split. And here I will change this to SK fold. Now if I do this, see here also you got approximately same accuracy. See 81.75, 82%. Now see if I change this number of fold to 10, let's say, that means 90 and 10%, let's say 10. So now if I'm doing this, is the accuracy changing? Little bit, right? Little bit, right? See, almost same accuracy you are getting. If I'm giving you 15, see 83. So little bit change you will get in the accuracy, not much change. Okay, so we generally take 5 or 10. Don't take more than 10, because more than 10 means you will take a very small samples of data. So you can take higher value also, but we don't prefer that. Okay, you can just try any random value here and you can pass that here. Okay, so this is what k-fold, this is what stratified. Now coming to the leave one out cross validation. Leave one out cross validation, which is also known as LOOCV. In short, we call it as LOOCV. Okay. So here I will write from SQL under border selection. I'll write here leave one out, leave one out. Okay, leave one out. Now here, let's say LOOCV, and here I will pass leave one out. Now here we don't have to pass any fold value here. Simply we will pass this, and here I will pass LOOCV. That's all. Now if I run this, now it will be time taking. It will be time taking. Okay, done. So see, we got the accuracy for each of the threshold, each of the fold, basically iterations. And overall, I got the accuracy of 85.25. See. So this is giving the better as compared to the previous one, but this will be very small, very time-taking process. Okay, so we don't prefer this for the larger data set. Okay, clear? Then the last one is repeated random train test split, which is shuffle split. Okay, so now here we will write shuffle split. Let's say shuffle. Okay, and here I will pass this shuffle split. Now as this shuffle split is a mixture of k-fold and your train test split also, so we have to pass both value here. Number of split also, how many split you want. So n underscore split is equal to, let's say I want total 10 fold, comma, you have to pass the test size or train size, anything you can pass. So let's say I want 80%, so I'll write here 0.8. So in each fold, it will take 80%, 20%. Okay. So now if I run this, and here we will pass shuffle. And here also random state will be there. Let's say 0. Just a minute. N underscore split is not taking here. Okay, it's N underscore splits. Okay, so here you can see 84.24 we got here. So this is how we apply different type of cross validation to your data. So according to me, you should try all and check your accuracy in each case and see how your model is performing. That's all. So this is your cross validation. So am I clear to everyone? Tell me, is that thing clear? Okay. Yeah, tell me participants, can I have some information? Okay, fine. Now we are going to discuss the feature selection. Feature selection. Let me tell you here only directly. So for this feature selection, I will take a new file. See, it doesn't depends on the data set. It depends on the model that you are using. All these things can be applied to any model, classification, regression, everything. But depends on the data set that you are using. If the data set is fine, depend on the model. If your data set that you are using, it is applied to any model, whether it is logistic, linear, or anything, then it is fine. It will be applied. Okay. So now, what is feature selection? As the name only tells you, selecting features, selecting the best feature. Let's say you have 50 columns. So how you will select out of 50 columns that which feature is important, which feature is not important, how you will select? So one way is that you select by the experience. Let's say you have a, you know that, let's say if we have a student data of marks, I know that marks will depend how much time the student is studying, how many days that student is attending the class. So these are the factors which will affect the marks. But if we have some data set where we don't know that thing, that which will affect the output or not, we have total 100 features, we have total 200 features, and not we are not able to decide that which feature is important and which feature is not important. So for that we have some 2-3 technique which we can use to do the feature selection. So the first technique that I'm going to tell you today is your univariate selection. Second one is your feature importance. And the third one is your correlation. And one of you asked me about correlation in my previous session. Are you present here? So that correlation thing I will cover today also. So these are the 3 things that we'll discuss today. Okay. So for this, I will use one data set which I have uploaded in the drive, and just a minute. Okay, so all of you download this data set. I am giving the link on the chat. This is the data set that we are going to use, and the collab file link. What? It doesn't depend on data set, Saurav? What you are asking? Ajay, are you in the WhatsApp group? In the WhatsApp group, just go and check the description. The drive link is there. Okay. What should I provide on WhatsApp? Data set. Wait. Just a minute. Okay, I provided that in the WhatsApp group also. You can check now. Okay. Sunil, all the collab link, all the collab files are uploaded in the drive. I made the drive already. It's all there in the drive. You can check the drive. You'll get all the day's files there. Okay. That's why I made the drive. Okay, now let me complete this and then I'll consider your doubts. Lokesh, I think you are coming to this session only for attendance. Every day you are asking for attendance only. See, I'm not here only for the attendance. If you're here for learning, just be for learning only. Every day you are asking for attendance. I'll already give the attendance whenever the time will be there. Okay, fine. Now, first of all, let's read that file. I'll discuss that Muna after some time. Wait. Let me complete the topic first. So data is equal to pd dot read underscore. Yeah, it's 9 p.m. Yes. It will be completed before that. It's a very small topic. Train.csv. Collab file is not working. No, it should work. Check it properly. It should work. I'm giving that link again on the chat. Check it. Okay. Now, if you see this data set, we have so many columns here. Now, can anybody tell me what is this data set for? Tell me, what is this data set for? Look at the columns, look at the column name, and try to figure it out. What is this data set for? Process of reducing number of input variables called feature selection. Yes, Sudarshan, you are correct. I have updated the link. You can check it now in the chat. Now it will open the feature selection one. Okay. Updated the link in the chat. Okay. So tell me, what is the data set for this data set? We have battery power. We have blue, clock speed, dual SIM, FC, 4G, internal memory. The name, you can just clearly understand by the name what is this data set for. This is for the mobile. Yes, for the mobile. So let's assume that we have to predict the price range of the mobile, based on these features. And if you see this price range, data of price underscore range dot unique, you'll get 3 values in this: 1, 2, and 3 and 0, 4 values. So we have 4 ranges of the price. So this is not a regression data set. This is the classification data set where you have total 4 class. So we don't have to apply machine learning here. You can apply that later on, but we just have to understand how can we select here the best feature. Out of all these, which feature is very much important for the price, or on which feature the price depends. Now, we have so many columns. Can anybody guess right now? Guess 2-3 features, which is the top most feature on which the price depend. You all have purchased mobile phone. I'm pretty sure that you all have purchased mobile phone from the market, and you must be knowing that the price of mobile phone depends on what feature. So according to all these columns, tell me which feature would be the very most important one according to you. Yes, battery power, RAM, memory, right? Whether it is 4G or not, 4G, clock speed. So these are some important features, right? So let's use these 3 techniques and let us see, are we getting these only or not? Are we getting these only or not? Let's see that. Okay. So first of all, let me tell you about the univariate selection. How to do this univariate selection. Now, whenever you go for these technique, you first of all decide that how many features you want. Whether you want top 10 features, whether you want top 15 features, so that you decide here. So, and that number of features, you can take it out. It's not only that it will give you only 10 features. That is totally in your hand. How many features you want to analyze? Let's say you have 20. So 20 features, I can say that I want top 10 features. I want top 15 features. Let's say. So based on the score, based on the value that I am getting, I can decide how many features I can take here. I can decide that how many features I can take here. So in this univariate selection, what do we do? Let me tell you now. Let me apply this and let me find out the best feature. So in this one, basically we select the K best feature. K best feature means the K value can be anything. It can be 10, it can be 20, it can be 15, whatever you want. That can be the K value here. So I will write here from sklearn dot feature underscore selection. This is the function. Import select K best. This is the library that we have to use. Select K best. And one more library you have to import, which is chi-square, chi-square, CHI2. You can read about this chi-square from Google, from any documentation. You can Google it out and you can find out. It's very simple. It's a chi-square test to find out the good data. Basically, it is related to the statistics. So it's a stat between the each non-negative feature and the class. And this is the formula for the chi-square. Okay. So you can read about this more from the documentation or from the Wikipedia and all. Okay. So this is a part of statistics. So we'll import these two library. Then we will write here. And one more thing. Let me separate this X and Y here. This is my Y and all other my X. So let me do that also. And if I'm writing this code, just tell me, do you all agree this or not? If I'm writing this code, is that correct or not? So I can write here data dot drop price range is equal to data dot. If I'm writing this, is that correct to split X and Y? Just tell me. I hope you all agree to this code. If I'm doing this, X will contain all your features. See, if I print X, I have dropped the price column. You can see here, the price column is not there. All the other features are there. Okay. And in Y, you will get only the price column. Okay. So if you have understood the pandas class, I hope these things are clear, everyone. Okay. Okay, fine. So now what I'll do is I'll take a variable here. Let's say best features equal to select K best. Now here I will pass how many features I want. So let's say I'll pass here that K equal to 10. I want top 10 features. Let's say I want top 10 features. And then you have to pass one score function, which will calculate the score of your feature, and that score will be calculated by chi-square. Okay. Now if I do this, let's take a function, a variable fit is equal to best features dot fit, and here it will pass X comma Y. So what this function will do actually, it will train the model with all the features one by one, and then it will see which feature is more important. Let's say in the first iteration, I am taking only the first column. Let's say I am taking only the first column. I got the accuracy of 70%. Let's say in the second iteration, I am taking the Bluetooth and battery power both, and my accuracy increased from 70 to 75. So tell me, in that case, will you consider Bluetooth or not? Is that Bluetooth will be the important or not if the accuracy is increasing? Tell me. Definitely yes, right? But in case, let's say I consider Bluetooth and my accuracy is not changing, or my accuracy is decreasing, so in that case I can say that this feature is not important. So like this, it does this operation and it calculates the score accordingly. Okay. So one by one, it takes for all the feature and then it decides which is important and which is not important. So now after this, what I will do is I will create a score variable scores, df of score equal to, let me create a blank data frame, df is equal to PD dot data frame. Okay, and here I will write here df of feature is equal to x dot columns. I'm taking all the columns name, and df of score. Now to get the score, I'll use this fit dot what was the function name, dot scores. Yeah, this one. Okay, that's all. Now if I print this df, okay, see here, we got that now. So let me sort this data. Df is equal to df dot sort underscore values. I want to sort this data through score, and ascending is false, and df. Okay. Okay, look here. Which feature is the most important? Look here. RAM. RAM is having the highest score. Then the size of the screen, height and width of the screen, battery power, mobile weight, internal memory, SCW. I don't know what is this SCW. It may be something. Then dock time, FC. This is all these are the important features that we have. If you want only the top 10 features, you can write here df dot head of 10. It will give you the top 10 features. So these are the top 10 features that we got after applying the univariate selection. Okay. So tell me, am I clear to all of you? Okay. Yeah. Now the other technique is your feature importance. Feature important is somewhat the same thing. Okay. Yeah, size square only. Yes, it may be some other score function also, but we use mostly size square only. Okay. Now this is also almost same, but here only the library is different. Library is different. Feature importance, and almost both of these will give the same result. Okay. Already I have shared the link. Just check the chat. In the chat there is a pinned message. Just click on that, you will get it. So from sklearn dot ensemble import extra trees classifier. Okay. Now here we will plot the data. That will be more better to visualize. Okay. So let's say model is equal to extra trees classifier, and here you will pass then model dot fit x comma y, and yeah, that's all. Now if I run this, done. Now if I write here model dot feature underscore importances, now these are the score we got for all the features. Now it will be always between 0 to 1. Okay. Now you can plot this if you want to plot. So I can do one thing. I can convert that into data frame or series, and I can plot that also. So I can write here, let's say feature importance equal to, feature importance equal to PD dot series, and here I will pass this because there is only one column, so no need of data frame. I'll simply take it as series only. Okay, and index will be my, or wait, let me take it in this way only, because this you all know, otherwise it will be a different one. Okay, so here it will be my this one and this one. I'll take it here. Okay, so here I'll say feature importance. Okay, see, so here we got that score. Now tell me, is it not similar to the last one that we got here? Tell me. Yes, it's Gujarati. I'll surely do that. See, tell me, is it not similar to the last result? Correct? See, you got in the form of a bar also. Okay, so like this we do. Okay, so this is your second way. Now coming to the last way, which is your correlation. Now correlation, here the value of correlation will be between -1 to +1. -1 represents negatively correlated. Negatively correlated means if one will increase, the other will decrease. +1 means positively correlated. If one will increase, the other will also increase. And 0 means no relation at all. No relation at all. So if I want to calculate the correlation thing, I can simply write here. Do you remember heat map that I covered in one session, in the data visualization session? Do you remember heat map? Tell me. So I'll plot using heat map for the proper better visualization. But let me show that first of all. So correlation will be CORR equal to data dot data we have now. So data dot core, simply data dot core, and see if you print this core, you'll get a very big matrix. See, a very big matrix. Now battery power versus battery power, obviously it will be very highly correlated, right? 100% correlated. If I'll take battery power versus battery power, so it's 1. Battery power versus Bluetooth, this is battery power versus clock speed. But we don't have to check with battery power, we have to check with the output. So let's go to the last column. See, this is the last column, price range. So price range versus battery power, this price range versus this. So wherever you have higher values in positive or in negative, then you can say that these are the important feature. So I can plot this in the form of a heat map for the proper visualization. So I can write here SNS dot heat map, and I can pass here core. And let's see. Okay, so PLT dot fig size, sorry, figure, PLT dot figure fig size equal to, let's say 10 cross 10. Okay, and not equal to annotation equal to true. Okay, we can see the values also, but it's not very much clear, but little bit of values I can see. I think 20 cross 20 will be better. 20 cross 20. Okay, look here now. So the lighter shade is higher value, +1. Okay. So if you see this red one here, if you consider the last column here, see the battery power is very important. Then this one, px height, px weight, RAM. So is it not the same that we have seen in the previous one? Tell me. Is it not the same? Somewhat same. Right? So if you want this result in this form, what I can do is, this core I can use. I can write here core dot sort underscore values. Right here I want to sort using price range in the descending order. Ascending equal to false. See now, we got that now. Let me print only the price range column. Okay, so these are the top 10 top features: RAM, battery power, pixel width, pixel height, internal memory. Now tell me, are they not same again? Are they not same again? What we got there? So whether you go for univariate selection, whether you go for feature importance, whether you go for heat map, you are going to get almost the same result. So these are the three different ways through which you can do the feature selection. Okay. So I hope you understood the today's session. And all of you present here, please hit the like button. 167 people are watching. Make it 150 at least. All of you hit the like button. I hope you are enjoying this session. So please do that thing for me. So that is all for today. So I hope you enjoyed everyone today. Now just tell me, do you want to extend this class on Saturday or Sunday? If you want that, tomorrow if you don't want to extend, tomorrow I'll cover the deployment. Otherwise, tomorrow I'll cover the clustering, the unsupervised class. So what do you want? Yeah, I'll take one day where I'll cover the clustering. If you want, I can do that. But I want good crowd on that day, not only 10-15 people. Okay. Okay, fine. Fine. So tomorrow I'll explain about the clustering, which is a part of unsupervised learning. Okay. And then on the last day, that is on Saturday, I'll explain about the deployment, how you can deploy your project. Okay. How you can make this project available for all the users. I'll cover k-means clustering and hierarchical clustering. These two clustering I'm going to cover. K-means clustering and hierarchical clustering. Okay. No, that is not possible, Girish. Maybe in some other session I will do that. I have covered much thing in this 2-week session. Whatever thing I feel that was important. Okay. No, from Monday I cannot do that. Monday I have my another schedule, so I cannot take the class from Monday. No, on Monday I cannot do that. Sorry. Monday I'm not free. In the next week I'm not free. I'm another schedule. Okay. Google Drive link is updated in the WhatsApp group. Just go to the WhatsApp group. In the description you will get the Google Drive. Okay. No, decision tree we are not going to cover. See, now whatever I think I have covered now you simply go to any YouTube, search for any video. Let's say you want to learn decision tree, search on YouTube decision tree, you will get so many videos, and now you will be able to understand the things, because now your concept are, your base is strong now. So if your base is strong, you will get everything understood now. Okay. Vamsi, what you are saying, Dr. Vamsi, web means what? No, Pradeep, I'll cover the deployment on the last day. Okay, so I'm sharing the attendance link. So before that, please everyone hit the like button. And if you're not subscribed to my channel, please subscribe to my channel and share with your friends and colleagues. No, right now I haven't thought about that. Maybe if I'll do that, I'll tell you. Yeah, why not? I already told you, validation is applied to a model. So if you are applying a model for a text data, you can do that. Yes, Ashish, I will do that definitely. Okay, I have given the attendance link. You can go and fill the form. And please do hit the like button, all of you. And before going to the form, before filling the form, please hit the like button. And then you go and fill the form. Yeah. So on Saturday, I will take the session, Sunil. Saturday. Sangeeta, in the deployment only, I will tell you web application. In the deployment class only. Web application is a part of deployment. That will be on Saturday. Okay. And on Saturday, there will be quiz also. So be prepared. I will be giving some questions, MCQs based on whatever I have discussed in the last 2 weeks. Okay. Saturday. Sangeeta, are you asking on Saturday? It is possible, but most of the participants are free on evening only. So let us take the time in evening on, that will be more better. No, we have not covered hypertuning. See, in these 2 weeks, how many topics we can cover? I have covered the most of the topics which I can cover in this duration of time. Obviously, I'm not saying that machine learning is completed. I'm not saying that. Correct. We have so many other topics also. Hypertuning we have, in which we have L1 regularization, L2 regularization. We have grid search, CV. So we have different other topics also. Okay. No, Japchit, in the next week I'm not free. I have another schedule, so I cannot take that in the next week. Deployment on Saturday. Tomorrow I'll tell you about the clustering. It's a part of unsupervised learning. That I'll tell you tomorrow. What is the need to cross validate when we get a cross validate? Makes you sure that the model is performing good in any situation, in any type of data. That is the need of cross validation. Okay. Saturday, same time, same time. Okay, then. So I hope you all have filled the attendance. So make sure you like my session and subscribe to my channel. I'll see you tomorrow for the next class. So take care, everyone. Good night. Stay safe and bye.